Hello and welcome to Solidworks Station. My name is Stuart, and in today's tutorial we're going to look at Solidworks Simulate, which is an add-in within Solidworks 2019, and we're going to look at a bit of finite element analysis, otherwise known as FEA. Any questions regarding this tutorial or any of my other tutorials, then please get in touch using the comment section below the video. Best of luck, and let's get started. So the first thing I'm going to do, we're going to look at FEA analysis using Solidworks Simulate using two different parts. We're going to create these and then we're going to look at a little bit of simulation as well. So I'm going to go into the Sketch tab. I'm going to go into my top plane for this one, normal 2. I'm going to sketch a center rectangle from the origin and I'm going to give it some smart dimensions. So let's go with 150 here. And let's go with 75 here. Okay, we're going to go to features and extrude this by 12. Okay, and green tick. Okay, so 150 by 75 by 12 piece of material. And from here we're going to go into the top plane, normal 2, and let's create another sketch. Let's go with a corner rectangle this time. Let's give it some smart dimensioning. So up to smart dimension, let's make this 50. Let's make this 20. And let's make a relation between the center of this rectangle, hold down control, and the origin, and let's make these horizontal. Smart dimension from the edge, 5mm, and we are now fully defined. Right. Let's place a extruded cut through all and green tick. Okay, let's place maybe a couple of fillets in here. 1, 2, let's do 4. 4 fillets, all at 10mm. And green tick. Okay. Now, from here, we're going to have a little look at the Solidworks Simulate. So, under the Simulation tab, if you've not got this, okay, it's due to simulation not being on here. So, okay, so you just right-click and ensure that simulation is up and running. You've also got to ensure that in the SolidWorks add-ins that you've got SolidWorks Simulate up and running here as well. Okay. Okay, so we're going to go into simulation and we're going to say new study. Now we're going to do a static study. As this is our first time, we're not going to go into any of the other ones, but there are lots to choose from. Okay, and we will be doing further tutorials in some of these as well. Okay, but for the time being, let's stay with the basics and let's go with a static study. So static study, you can name the study if you want. So let's call this Solidworks Station Static Study 001. Okay, and green tick. Now, we haven't applied a material to this. So that's the next step that we need to do. So I generally work across these tabs within the simulation tool. So I apply a material next. Let's go with alloy steel. So there's loads to choose from, alright, under SolidWorks material. Okay, there's iron, copper, titanium, lots of different things to choose from. We're going to go with steel, and we're going to go with alloy steel. Okay, again, you can change lots of different things in here, alright, but this is going into far too much detail for this tutorial. We're just going to keep it nice and simple and just stick with the default settings. So we're going to go apply and close. You'll notice now the colours change slightly of the component part that we've produced. So we're going to move down again. So fixtures advisor. Just click on this flyer option here, and we want in this study to create a fixed geometry. So we're going to left click on fixed geometry. Okay, and it's asking us the standard fixed geometry. Is it fixed? Is it ruler or slider, or is it a fixed hinge? Ours is fixed geometry. All right, so we're going to say that this part here, okay, is going to be fixed into a load bearing or non-load bearing wall, let's say. Okay, there's some advanced settings here. Okay, again, we're not going to go into these in too much detail, as this is just a basic tutorial on SolidWorks Simulate. So let's go ahead and click on the green tick. It says please select a reference plane axis, edge, planar or cylindrical face for the reference. So let's just have a little look what went on there. Let's close this down. Standard, fixed, yeah, and green tick. That's probably because we had the advanced settings open. So now that we've got that into position, we're going to move across again, and it says external loads advisor. So we want to create a force that we're going to place down on this particular part, and it's asking us, is it a downwards force like so, or are we using a torque, more of a rotational force? We're using a force, and we're going to go and select this edge here. Okay, now if I just zoom in, you can see that the force is actually coming towards me, with the arrows that are indicated. Okay, if I hover over these, there's more forces that we can apply. However, I want to place this arrow in the downwards direction. So to do that, I need to click on selected direction and then just select this line here, and you can notice now that these arrows are going down. Okay, the units that we're going to use, all right, are going to be the standard SI units. However, you can go in English or metric. Okay, so the IPS or metric G. However, we're going to stick with the SI. The force that we're going to apply is going to be 1000 newtons. Okay, and we're going to green tick. Okay, we're going to run this study now. So we're going to click on run the study. And it's solving it now. Okay, perfect. So what we get now, all right, is a chart here on the right hand side, and this is indicating our stress. Okay, so the results that it's provided us with are stress, displacement and strain. Now if I go into stress, okay, the areas here in green, okay, are indicated on this chart here, showing us newtons per meter squared. Now we're working in millimeters, so it's a good idea maybe to get this into newtons per millimeter squared. So we can right click on this table, we can go to edit definition, and here you can see we're on newtons per meter squared. Let's change that to newtons per millimeter squared. Okay, and green tick. Okay, so that's now changed over here. You can see the areas of blue. Okay, you can see the areas of green, red, maybe a little bit of yellow in there. To get a little bit more of an accurate reading, it's quite good having the colours, but to actually know exactly the figure that you're looking at in a particular region, you can actually use a probe tool. So to do that, you would right click on stress, for example. You would click on probe, and you could actually click on, zoom in and click on a particular area of interest. So here, for example, just left click. Okay, drag this out, and we've selected a node point here. This is the reference for that node, and you can see the X, Y, and Z location that's been given, and we've got a value there, okay, of 2.038 newtons per millimeters squared. Okay, just show you that again. So this is the probe result. Okay, it gives us a summary, an average, a maximum, and minimum. Okay, lots of information there that we can read. Okay, I'm going to go and just green tick this. Okay, I'll just show you that again. So we right click on stress, we go to probe. Okay, we can zoom into a particular area, let's say over here, left click, and drag that out. This is node number 287, an X, Y, and Z location, and a value of 2.499 newtons per millimeters squared. What if then we wanted to find a region that was almost within inside this kind of section? What we could do is right click here. We could go to section clipping. It clips the part. We could say OK to that. Then we could go and right click, go to our probe, and probe inside here. Okay, left click, and we get a new location, new X, Y, and Z location, and a new value as well. So two ways of doing that. Okay, clicking on the outside of the part that we created, or creating a section view and doing it that way instead. Okay, let's have a look at displacement. So right click, and we're going to go to show. Okay, so this is a little bit different. Okay, the areas here, okay, that are attached to our load bearing or non-load bearing wall are over here, and you can see that the displacement is not too bad in this area. Okay, we're down here at the chart of about 1. However, our displacement, as we get further towards the point of our load, obviously increases quite high up the chart to around 9. Okay, again we could right click here and we could use our probe in order to see where we need to maybe improve this particular design. Finally, we've got strain. Right click and show. Okay, and we can see the strain that this particular product is going through. Something else that I'd like to show you is if I just right click on one of these results, this one for example, strain, and we go to compared results. Okay, and green tick. What that will actually do, it's quite nice actually, it will show us the stress in here, it will show us the strain in this window, it will show us the displacement in this window, and it will show us our model in this window as well, which is quite a nice feature in SolidWorks. You can have 4 windows up there looking in each of these particular areas: stress, strain, and displacement. Some configurations that you can do as well with the table. We can right click on the table, we can go to chart options, you can click in this field here, so show minimum annotation. Okay, so the minimum amount of strain at this point is 1.867. That's the minimum value on this product. We can say show maximum. Okay, so in this area here, that's where it's at our highest, so 9.284. Okay, we've also got the position of this chart where we prefer it to be once it opens up. It can be on our right hand side, it can be here in this position, or it can be over at our left hand side. We can move it as well, okay, across using these buttons, okay, up and down using these ones. We can have thick bars, normal or thin, and we can show the information here. Let me just move this across so it's a bit more visible. We can show the information that we have scientifically. We can show it floating, or we can show it in general. I generally stick with scientific. Decimal places as well. Okay, you can increase the number of decimals here. Okay, so that's quite useful. All right, you've got color options in here as well. Okay, the default bar is like that. You can have it as rainbow, grayscale. Okay, user defined. You can define your own in there, or optimize for color blindness as well. Okay, which is quite useful, quite a handy tool to have. We'll stick with the default one, and we'll click on the green tick. Okay, one more thing that I'm going to show you before the end of this tutorial. I'm going to show you how to create an animation of this particular result. So if we right click, let's say on stress, go up to animate, you can see an animation is being created. It's calculating the frames there. You might find, I'm just going to press stop here, you might find that your frames per second here are quite low. Let's say if it was 5 for example, okay, you'll see that it moves quite quickly. Okay, so just change this to a higher value, say 50. It'll take a bit of time to calculate. Once it has done, okay, you'll see that that now is animating nicely. Perfect. So that has been a tutorial around a very simple study on simulation, SolidWorks simulation, and a bit of finite element analysis. We've looked at a few things in this tutorial. We've looked at stress, displacement and strain. We've looked at creating fixed parts. We've looked at creating a force with a certain amount of newtons applied to that. We've looked at how to look at these results, how to configure this table, how to change things in this table, and also how to animate. I hope that's been enjoyable, and I hope it's been worthwhile, and I hope you get a chance to have a little go at that and see if you can find out some more features within SolidWorks Simulate that you can manipulate and test your knowledge on and bet yourself in the program. Thank you very much for listening. This has been Solidworks Station. As always, if you've got any questions or comments, then please leave those below. Don't forget to like and subscribe, and join me again for another video tutorial on this program.